guys, welcome back to another Inspire workshop. I'm so excited to be here and I'm so excited to introduce our speaker, DrakeRose. And reminder that all of the workshops will have 2 live challenges, so make sure that when they pop up, you scan that QR code. But Drake, how are you feeling?
Feeling great. I'm ready to get into this, honestly.
Awesome. So I'll let the floor be yours and go take it away.
Cool. All right. So yeah, hey everyone. It's nice to meet you all. Today I'm going to be covering AI and Roblox Studio, best practices with LLMs and MCP. I really hope you find this workshop informative and a great learning experience. Okay. So, but first I'd like to introduce a little bit about myself. So my name is DrakeRose. I'm 28 years old. I've been with Voldex for 4 years now, and recently I'm now the director of engineering. I've been on the Roblox platform since 2008 as a longtime player and creator. I have a bachelor's degree in computer science from the University of Silicon Valley. I also love to cook and spend time with my family. And I've started out by launching my first game called Derby Wars, and that was essentially a springboard into joining Voldex. And since I joined Voldex, I've had the opportunity to create for some of the major games like Encounters, Driving Empire, and Brookhaven. Cool. So let's get into our agenda for today. So we're going to be talking about why does AI and MCP matter? And I'm going to be telling you what MCP is. And then there's going to be a demo of me building with MCP. And throughout that process of me building, I'm going to be describing some learned best practices. And then we'll conclude with a Q&A. Okay. But before we begin, I want to highlight some prerequisites. The workshop assumes that you have an intermediate level of knowledge in coding in Roblox. So you do have a basic understanding of how frameworks work. You also have an understanding of Luau and are comfortable with writing code. And you understand how to build with inside Roblox Studio itself. You have Rojo installed. You can sync code locally in the studio with Rojo. And you have an external IDE. And for today, I'm going to be using Cursor. Cursor is a fork of VS Code, and it has an agent harness inside of it. And this is essentially what's going to allow me to make the code changes with AI and call functions via MCP. For a disclaimer too, for an IDE like Cursor, you'll need to have a subscription when accessing various providers that that are surfaced on Cursor. So just to highlight that. Okay, so why does AI and MCP matter? From my experience, you write less boilerplate. When the AI is leveraged properly, it'll ensure clean reusability of code and create very structured systems that are pretty well documented and easily understandable for any engineer to really dive into. And AI really shifts you having to think about how you're going to write your code into thinking about your game in terms of systems, designs, and gameplay loops. So from my experience, the iteration is so much faster. You can make changes rapidly with AI and test in Studio, and it's much more beneficial than having to really deeply think about how to write the code and in what way. I still want to emphasize, though, that having a knowledge of programming is essentially a multiplier. Learning how to code is still valuable in my eyes. It gives you the know-how for knowing how the system should be structured and constructed through just words alone. So what is MCP? Well, MCP is an acronym for Model Context Protocol. And MCP essentially serves as the bridge between your AI model and the software for which you're working in, which is Studio for this instance. And MCP essentially provides the context format for how the AI should talk to Roblox Studio to directly control it. So this is essentially how AI interfaces with popular softwares today. So why is this really useful, though? AI becomes more useful when you can allow it to inspect your actual project, like calling tools, making changes, and helping you test, all for you. Chat alone just gives you suggestions and reasoning, but when you expose MCP, you're allowing the AI to make decisions around its own reasoning for Roblox Studio. Yeah, so you're able to be able to read, understand the data model, properties, the composition of your project, and from there it can drive changes directly into Studio. Excellent. So on that note, what are we building today? For this exercise, I'm going to be walking you through how to build a small game with AI and MCP. And I just want to be clear, I'm not going to just prompt and hope this all lands. I have prepared prompts ahead of time, and we'll walk through it. But the process is going to follow something like this. I'm going to ask for one feature from a plan. So I'm going to provide a plan to the AI. We're going to iterate if necessary. You generally want to iterate if you see it's not quite there. And we're going to test it immediately after to make sure the changes do work. And then I'm just going to describe essentially what's going on and what changed. And then we'll just move on to the next feature. And then along the way, I'm going to share like essentially what these best practices are made up for each and every single step. And the goal of this is that you walk away with a tree clicking simulator. A few things I want to highlight though before we start is that you should still plan and review your implementations and test and iterate. It's important that when even though you're building with AI, you still would want to build a quality game, and that requires intention and iteration. So starting with the GDD is still important. You should break down your systems into necessary plans for how you want the AI to execute against it. And you can use AI to essentially help you plan very complex systems from your GDD. So from my experience, the best workflow hasn't been fully autonomous. It's iterative. AI should not completely replace all of your decision making. You still need to be intentional about decisions on how the system should be constructed. Yeah. One other thing is that making a game takes a lot of work. There's a lot of creativity involved. It is hard. So this demonstration is simply coming from the angle that we're prototyping a simple game as a proof of concept. Okay, so let me go ahead and switch the slides real quick to. I'm going to share my whole screen. Okay, I think we're good. Okay, so yeah, left side I have Studio, and on the right I do have my cursor, and I did slot it in a way where it fits nicely. So if the AI was doing things, you'd be able to easily see it, make the changes within Studio. We're going to be using Opus 4.8 by Anthropic, and I have it on high and fast. I want to be clear that like for a model like Opus 4.8, it's pretty intelligent. It is also costly. So you do get excellent intelligence, and what I've recognized is that when you do have that level of reasoning and intelligence with a model like this, you can explain less and still get what you want, but you should still have ground truths into what you're actually planning out. So yeah, I also want to go ahead and cover how to set up MCP because that's important. This is Roblox's assistant. I went up here in the top right corner of Studio and clicked the AI assistant button right here. And you can also use their AI to drive the changes similar to what I'm doing here. But since I'm using an external IDE like Cursor, I want to go ahead and tell Roblox Studio, hey, look, you can talk with Cursor, or Cursor could talk to Studio. Button and top right, see 3 dotted buttons. And what I would do is I would tick the enable Studio as MCP server, and then I would tick Cursor. And if that doesn't work, you can go ahead and click the setup instructions. There's a JSON you can copy, and then you can come into your MCP inside of Cursor, and you can edit your configuration and set it up from there. Okay, so since it's already set up, we won't do any adjustments there. Awesome. Okay, so one thing I want to highlight is that throughout this whole process, my mental model with MCP is that if it requires like a data model change, reading things from the data model, I leverage MCP that way. If it's not, I'll explicitly state through my plans that I don't want you to use MCP here. If you leave it vague, the AI will just assume which is going to be the best thing to use. So you may get MCP usage that actually wasn't necessary. And you'll see instances where I basically put that constraint in. Okay, so what I want to do is I want to go ahead and step into the architecture of this project. So I have an architecture MD file, and this is pretty much like an agent MD file, but the architecture essentially breaks down the foundation of how my project is structured. So we can see that there's various containers here, like replicated storage, server script service, starter player. I'm essentially telling the AI, hey, this is the high-level architecture of my game and how I'm wanting to structure it. So you can see here I provide like NIT. NIT is by Sleepnik, great framework, by the way. Just a good shout out there. But it really has in there like services, like the services, which are server singletons, and controllers, which are client singletons. And there's some other high-level stuff, like I'm using components by Sleepnik, a networking layer, profile service for data persistence, and CMDR for like administration. But essentially, you don't want game systems in here. You just want the high-level architecture of how your game is structured. And this is essentially the jumping off point for the AI to know how to build against your systems that you want. Cool. So let's go ahead and jump into the first step. So we are creating a prototype of a tree cutting simulator. I list out the requirements here. which is this is a constraint. Only use MCP to make the data model change. Do not implement the logic yet. And then I describe essentially what do I want. So I want you to create 2 folders in workspace.GameMap, and this is another good practice where I tell it explicitly where I want it. This is called hinting, and you can see this. I do this pretty often throughout these steps. So I do workspace.GameMap.cellLogs, and that essentially is a model that already exists within inside our game map, which is right here. And I do provide some additional hints, like there's this attachment called bottom surface point, and that essentially gives the context to the AI of like, okay, that is where the surface is at. Okay. And I also then give it a verification criteria, which is another good practice. I'm saying that you need to verify the paths are created and visible in the game, and they are clearly labeled with text above them. And it's going to do that by taking screenshots. Okay, so we're going to tell it to read the architecture and execute against step 1. Okay, so it's going to begin reading the architecture. It's going to understand how the project's actually structured, and then it's going to begin to execute against step 1. And what I'm going to do here is, since there's an MCP change, I really want to make sure that you guys can see it happen in real time. So it is now, okay, so it is inspecting the current workspace.GameMap, and that's exactly what I highlighted, so that's great, it picked it up. Okay, now it's going to inspect the structure and find the spawn location. It sees if there's empty models. It wants the pads built. So now it's going to go ahead and figure out how it should build that. So we should see that build here in a moment. But from my experience, this can also extend to UI. And what I like to do for UI is I essentially like to block it out as a rough kind of like block out with frames. And I'll provide like reference imagery. And with that reference imagery, I will describe what I want, and then it will essentially build it out into that shape. Cool. So it succeeded here. It did build the pads, and you can see on the right side is now verifying that the labels are above there and the pads do exist. And let's see what it thinks. Okay, yeah, it finished. Great. These look amazing. So we have our cell logs pad and our upgrade with click strength pad here. Cool. So now that we've done step 1, let's go ahead and move on to step 2. So this best practice here is really grounding this basically the step in architecture. I want the AI to review to the documentation architecture for the game, and we are only creating a leaderboard system. And then of course I set the explicit requirement: do not use MCP. And then I'm essentially using the terminology around the architecture document, like create a service for leader stats for each player, and then I describe what each leader stat is. I also do initial values, which this is important to do. It's another best practice. Don't let the AI guess what those numbers are. It'll just come up with something. So really describe what those values would look like, and then I just tell it add some methods for my service. And I'm also going to go ahead and execute against this step. So execute against step 2. Cool. And it is going to execute against it. Yeah. So one other thing I want to highlight here is when it does, from my own experiences, when I am building like with systems against a GDD, I will think about every aspect of it. It'll be like the networking, the data persistence, how like the replication should occur from like a server to a client, and all that from my experience is very valuable. You want to think about how your system's overall going to connect around the overall architecture of your project. Okay, so it finished the leaderboard service. So let's just go ahead and take a look at that real quick. This looks great. It's going to create a leader stats folder for every single player, and each player is going to get a logs, cache, and act strength. And we do have the methods in here, and it simply goes through and adds that stat to every single player. I want to go in and just test that real quick to make sure that exists. So let me go ahead and do that. And it does. We have our logs, our act strength, and cache. Great. So we're going to go ahead and now move on to step 3, which is creating trees. And then this is another good practice, which is I'm doing asset referencing. So it is similar to like hinting around things around the data model, but asset referencing is essentially telling the AI, here's the assets you need to use, and then I tell the AI with hinting, this is where things need to go, and this is what you should be looking at. So for this one, I wanted to create a bunch of trees with MCP only, and each tree is going to need click detectors, so we can click on them. I'm also setting up the stats ahead of time. You don't have to do it this way. You can do it later in the project. I just want to get this out now. And then there's for small trees, there's going to be like low health, medium trees, medium, large trees is going to have high health. And then there's going to be 3 tree zones. And these 3 tree zones are right here. So we're going to have our small zone, our medium zone, our large zone. Great. And the thing is with this, I didn't explicitly asset reference because I'm also showing that it's, or hint, because I'm showing that you really don't need to always explain it. If you have a really intelligent model, it will go and find it and reason about on how to, where that zone comes from. So yeah. So for every zone, I'm also describing the quantities of trees. If you like, again, if you don't put anything here, like when I didn't put anything here originally, I got like 100 trees, and it was just like it was a cloud of trees that did not make any sense. So it's important to just really be specific. And then I'm telling it to verify, obviously, that there are trees within the zone, and it's going to do that by using the screenshots. Okay, so we're going to tell it to execute against step 3. So now it's going to go ahead and read it, and it's going to look at the tree that we have here. This is our tree asset, by the way, and these are some other assets we're going to use later. But yeah, so now it's reasoning about the tree. It's looking at the volume of what the tree encompasses. It's now figuring out, okay, you know, each element in that tree needs a click detector, and yeah, it's going to start constructing the trees within that zone. Oh wow, so it didn't do it correctly. I've never had this problem, and I think this is a great point where the AI might catch it. So it's going to begin to verify. Okay, so it's verifying from top down, so it may not get it, but this is where I would iterate with it, and I would go ahead and tell it, hey, this doesn't look right. Trees are floating, and then we'll see if it can correct the trees. So I'll go ahead and start writing that now. The trees don't look right. They're floating. Can you fix that? And let's go see what it does. And occasionally when you see my camera kind of freak out, that's the AI just taking control of the camera and moving things around. So let's go ahead and see what it does. Yeah, I'd actually never had this happen during my rehearsals. So it's kind of cool to see I get to actually like iterate with it and tell it to basically go back and diagnose the problem. So let's see what it comes up with. Okay, so it sees the issue now. It sees that the pivot has changed. Okay, great. It did a good job fixing it. And now it's verifying that the trees are seated. So yeah, so sometimes AI can be wrong. You know, it took a photo from above. Obviously, it is skewed perspective. It couldn't see that horizontal like bit. It wasn't leveled, and it assumed things were great. So you could let AI like verify your result, but sometimes it could be unreliable. You should generally just manually test the work. Great, but the trees look great. It did exactly what I wanted. It has a small zone here, medium zone, large zone, and the densities is different via the different zones. Okay, we can now move on to the next step, which is our challenge question. Okay, so what does MCP offer to an external AI? And I'll guys give you 30 seconds for that. Should be pretty obvious with the answers, but you know. Okay, we'll still give this 10 more seconds. Great, awesome. Okay, so assuming everybody has got it, we're going to go ahead and move on to the next step, which is timber. We want the trees to begin to knock down. And what's going on here is that we're going to be using a plan because this document here is actually quite complex. There's a lot going on here. First off, we have a health bar that we need to construct. We need a tree that can be clicked, and it has that behavior where it could be chopped, and it reduces it via the player's axe strength. And then we have some feedback, like tree's going to shake slightly. It could fall over too when we're done chopping it. And then there's some networking edge cases here, like the player should only see the highlights flashing when it is the local player. And then I begin describing the log drop system that when the tree gets chopped down, I want it to create physical logs in workspace drop logs. Okay, so this is combining various good practices, as you can see, referencing constraints, hinting, and I'm also being descriptive in the feedback. But this is a really complex plan, so I'm going to want to go ahead and execute against this using planning mode in Cursor. Roblox Studio Assistant also has a plan mode for developing plans. So yeah, but it's for something like this, I don't trust just throwing all this at it and assuming it's going to do it all. I actually want to see what its approach is going to be because there's a lot of changes going on here and it's pretty comprehensive. So it's not good to just throw all this and assume it's just going to run with it. With a plan, you can actually audit what it's about to do. And from my experience, I rarely just accept the first plan that it presents to me. I'll usually go back at it and iterate and then accept it. But sometimes, yeah, it does throw out a really good plan, and then we'll go ahead and run with it. So right now it is inspecting components. It knew that components exist. I'm highlighting that I want to use components. It doesn't know the underlying details about components, so it knows it needs to go and discover that. So that's what it's doing right now. And yeah, we should see what it creates. But yeah, like I said, this is a pretty comprehensive plan. It's it's got MCP usage for the health bar. It's got creating code for the tree itself, so making a few components, and then I'm emphasizing client feedback, and then the logs that should drop from it. So it is something that I would definitely want to make sure we have a plan for. And the great thing is that when you want to develop a plan like this, when you have a G2D, you could take a single system or multiple systems for that matter, and then break those apart with AI into how it should fit within your architecture of your game. It's very important to not just fresh context window with where the AI has no context about how your game actually is structured or what's available. Just telling it I want the system built, because at the end of the day, it's going to have to connect to the overall game itself. So yeah, it is still reasoning about the plan, and it's reasoning about how the tree falling should work. And now it's looking at the click detector behavior and how it should fire on the server side. And ultimately, at the end of this, it's going to present to me a plan, and it's going to go ahead and be an MD file where I can go through and we can see the diagrams that it creates and whatnot. Okay, so it is doing some inspections of does remotes exist, what's the logs composition, and does the drop logs folders exist? And yeah, we should see a plan come out of here pretty close to soon. Planning does take some time because you are allowing the AI to deeply reason about your ask. So yeah, it is now creating the plan. So it says here that it has enough context. It's going to go ahead and generate these files, and let's see here. Okay, here it is. It's built the plan. I should be able to view this plan right here. Okay, so here's the overall architecture of essentially of this whole entire plan. Is that we have our click detector. When it's clicked, it's going to read the act strength from the leaderboard service. It is then going to go ahead and update the UI for the player damaging the tree. It's then going to trigger the feedback mechanism, and it's going to reduce health of the tree. And it's then going to signal the tree fall signal when the tree has fallen, and it's going to then drop some logs. There are some design assumptions in here. So log drops are all occurring in the workspace.gamemap.drop logs place or folder. It is also going to give a tag to every single tree called tree, and that's where the code's going to run off of. It's going to make sure that the server is authoritative for health, chop timing, log drops, and respawn. It's also emphasizing what is going to be the actual MCP work, which is making sure that each tree has a tag. It's going to build the UI with frames and whatnot. And then you can see it's following the architecture of the overall code base, which we're going to use components for the trees and whatnot. And yeah, and then it's describing how it's going to use networking. I'm not going to use the verification. I don't want the verification step here because it is going to take some time, and we don't have playtesting agent enabled. So I'm going to go ahead and tell it to execute against this plan. Okay. So for the playtesting agent, I want to emphasize that too, is that there's a beta that is the playtesting agent from Roblox, and it does allow essentially an AI to go in during play mode and test your game. One thing I found is that it's still early beta, so they're still working on it. And for this exercise, it will be a little bit too slow to go through and have it automatically test. So when we do get a result, we're going to test it ourselves. Great. So it seems that it has tagged all the trees. So let's just go ahead and view that is true. It did. So all trees now have a tag here called tree. You can see it right here. Awesome. And now it should be building the tree GUI here now. It looks like it did. Great. So let's just take a look at that real quick. I'm going to go ahead and go in here, go to visible. That looks amazing. Looks great. It did exactly what I wanted. So we'll hide that because that was its initial state. And let's let's see here. So right now it is reasoning about how to construct the code behind the tree for both the client and server. So yeah, it's really cool to see how it's reasoning. And one thing I also want to highlight is a good practice. Watch its reasoning. Just look at it from from the key points and what it's doing, because sometimes the AI will begin to lean into things that don't make sense. Like it'll think that there's a problem, like maybe the code wasn't synced, or it'll think that something wasn't set up correctly. If it begins to go off rails, you could just stop the AI in its tracks and then tell it in a follow-up, hey, ignore that, focus on this. If you just say go to the next step, it's going to think, oh, I need to still go back and like correct that step. So you need to be explicit in telling it, this is done. Don't look at this anymore. Let's move on. Great. So let's go ahead and look at what it created here. So it created a tree server code here, and this is going to take the values from underneath the tree, which is the max health, the health, the log reward. It's going to create some networked events underneath that tree, and it's going to go ahead and wire up all the click detector descendants. For when a player clicks on it, it's going to create this chopping behavior, and it's going to basically take the health or the axe strength, reduce the health by that. Tell the clients, hey, look, you're attacking the tree, and then give it that feedback of it flashing and whatnot. And this should all look really good. Okay, so it also did the controller, the tree health bar controller here. You could see that it does have the networking in here where it receives the updates. It updates the health internally, or the progress of the health. And it also created the log drop service as well. So when a tree has fell, it's going to then drop some logs, which is then going to go through and clone that log template, set some attributes on it, give it some random spin, and then put it on the ground. Awesome. Okay, so it's now verifying. I don't think I want to do this, and this is a great example where I don't want to verify it. I believe that it's done. I am synced with Rojo, so we should be in a good state to go and test it. So let's give it a shot. So I'm going to run out here, and there we go. That looks great. Look at that. The health bar shakes. The tree is shaking as well. We can't pick up the logs yet because we didn't tell it to do that yet, but this looks amazing. Front page quality game. Okay, so we're going to go ahead and now we're going to move on to the next step. And that step is going to be, let's see here. I'm going to go back over here. Picking up the logs. Again, so this is kind of reiterating the same practices I've been emphasizing, with only one new thing here, which is server authority. And I emphasize that it is important. We don't want players to, fire a remote to the server and say, I picked up this log, and then they just fire it for an exploiter comes in, they fire it for all logs, and now the client stole everybody's logs. So it's important to be explicit about server authorities. You want to set an explicit constraint. So we're going to go ahead and execute against step 6, and I'll go ahead and read that as well. So yeah, I'm telling you, do not use MCP to make data model changes. We just want to make a server component which handles the log pickup. You should add clear comments. When the player touches the log, it should be removed, and we'll use the leaderstat service to update the player's log score. And then of course I describe essentially like the server authority bit of it. All pickup should happen on the server side. The server owns the log state as well. Client can't just claim it. And then there's an edge case prevent race conditions where two players race to a log, they both touch it. Who actually gets the log, right? It should be the first recognition of it being touched. And yeah, so it is now going in and constructing this log. So we'll go ahead and see what it does. Okay. So I think it's going back and verifying it. I think I forgot to go back and tell it to, it's trying to go back to step 5 and verify that it worked, because I did stop it along the way. So I'm going to say, don't focus on step 5, continue on with step 6. So again, this is important. I looked at it. I saw that I didn't explicitly tell it to, I told it to go to the next step, but I didn't tell it to stop what it was previously doing. So then it tried to go back and do what it was previously doing. So I basically say, hey, look, don't focus on that anymore. We're good. We already verified it. So yeah, let's just see what it does. It should be constructing the log service here. And yeah, so let's see. Okay, so now it is creating the log drop server component, and it's going to have all that code. It's also going to verify via playtest. I'm not gonna allow it to verify it. Like I said, I don't have playtesting agent enabled right now, and I could just verify it myself easily by just going in. I don't have to waste tokens letting it verify the work for me. After all, it is pretty simple. In that note, I would say, like, when you are verifying your work with the playtesting agent, you want to do it against more like complex step-by-step kind of flows. Playtesting agent right now, the thing that they're figuring out is like how to make sure it's more real time, because it's not really good with fast-paced games at the moment. So yeah, it can handle though like step-by-step actions pretty well. Okay, so it did create the log drop server component. This looks great. So when we do touch the model, it's going to increment our logs by using the leaderboard service. It's then going to then play a removal, which the log expands and disappears, and that should look good. Okay, so I'm going to go ahead and stop it and not have it test for me, and we're going to go ahead and test it ourselves. Okay, so I'm destroying the tree. The tree falls over. There's the logs. Yeah, and then can we collect them? Excellent. And you can see our log counter has now went up. Awesome. Okay. So I do want to make it so we could sell these logs now. And let's go ahead and go to the sell logs. So we're at step, let's see, we're at step 6. We're now going to go to step 7. And this is essentially how I'm getting towards the end of the steps, but this is essentially how I approach it. I have my requirements. Thing I want, the behaviors around it. Like, one of the new practices here is that when you do create, like, let's say a notification system. So for example, when I destroy the tree, or like I'm not destroying the tree, but when I'm stepping on the sell pad and I'm selling the logs, there should be a message that comes up. And that message will say something like, oh, this is the number of logs sold for this amount of cash. I'm also going to use this at other places. So essentially what I'm going to do here is I'm going to create the system. And when I do use it for like the upgrade pad, I'm going to highlight that you need to reuse the system. So reusability is important. So we're going to go ahead and execute against step 7. Okay. Awesome. And yeah, so that this is again, this is containing pretty much everything what I've described. You can see I'm doing initial value setting here. I have I'm using rules. So 1 logs equal 5 cash. I'm describing what the behavior should look like. I'm highlighting edge cases that could happen. I'm highlighting some very simple feedback and how would that essentially be built out. And I'm being explicit about like what would that look like. It should be visible for 2 seconds. It should fade out after 2 seconds. And yeah, so we should see how this looks. Okay, so right now it is thinking about wiring up the message controller and the cell pad service. So it should begin building that now. Great. So it is executing on the messaging controller for the client. So this is going to be the controller that's going to communicate the message on the screen that you did something. And it's going to start now on the cell pad service, which is the server singleton for architecture. And when you step on the pad, it's going to sell the logs off. And then that's going to obviously it's going to communicate to a messaging service to tell the client, hey, look, you sold something. Cool. So let's go ahead and take a look at the cell pad service real quick. Just take a look at that. Yep, this looks good. It did consider the debalance. It did have the rule in here. So cash per log is 5. And now when I touch the pad, it's going to go ahead and try a sell. Here's the debalance check. Here's another edge case. You can't sell nothing. And it's then going to tell me, hey, look, this is what your cash is going to be. And it's going to communicate that directly to the clients. Cool. Let's see here. Okay, so it actually did some of the playtesting while I was describing that, which is kind of funny. But I want to go ahead and test it myself. So I'm going to go ahead and destroy this tree. Awesome. Logs got produced. Let me destroy one more. Excellent. And now I'm going to sell the logs. There it is. So we just got 20 cash now. We're rich. We got a lot of cash. All right. So we're going to go ahead and move on to the next step here, which is going to be our challenge question. Okay. So I'm going to give you guys 30 seconds, but how do you ensure your AI stays on track when you're building features? Cool. So we'll have just 10 more seconds. Awesome. Okay, so let's move on to the click upgrade. Again, same practices. The only thing is that I'm throwing in rules. Like there's a costing formula here for how the click upgrade should work. So I want the click upgrade to scale with time, or scale with the amount of essentially the axe strength that I have. So as I get more stronger, it gets harder to obviously buy that upgrade. And and I describe essentially more rules, or that's essentially the rule, but I describe it, how does this triggering actually work. So if the player has enough cash, so if they meet the cost of this, we're going to subtract the cost and increase the axe strength by 1. And then I obviously highlight the player feedback that we should flash a simple message on the screen. You upgraded click strength to this. The message should be visible for 2 seconds. It should be red and bold, and then I highlight the edge cases. And yeah, that is essentially the practice for that. Is setting up rules, and scaling is good for when you're playing with numbers. So let's go ahead and go into step 9. So I'm telling you to execute against step 9. And after this, we actually should have a full game. Like you could harvest the trees, get the logs, you could sell off the logs, upgrade your click strength, go chop trees faster, and then go in more distant into the forest to chop the stronger trees to get more logs. So this is all coming together really well. Okay, so is now going to go ahead and tweak the message controller a little bit to support some of that color. And it's going to go ahead and now create the upgrade click service. So we should see that produced here. Got it. Excellent. And well, let's see what this looks like. So the cost per level is now 10. It has the upgrade debounce. That's the edge case I was highlighting. And you can see here it subtracts the when I upgrade, it subtracts the logs, and it gives me the axe strength. Cool. And then you can see here it's communicating the message. And it interestingly enough switched to rich text. You could set that as an explicit constraint, like don't switch to rich text, just support the color. But I didn't do it for this. So it just made an assumption that that's fine. In some cases it isn't fine. It can be rich text can land blurry sometimes in some cases, depending on how you use it. But yeah, it is going ahead and verify that the click upgrade works. I'm gonna let it go too, because I think we have enough time to allow it to do this. So let's see what it does to test the upgrade. So it gave itself the logs, so it cheated a little bit, and it then it gave itself the cache, and then it went to the click upgrade and saw that it's changing. So it is still testing to see if it can keep going, and it's verifying that the math is working out. It's then taking a photo, and it took a photo of exactly when that message popped up. So it's done. It looks like it did a good job. And we're going to go ahead and now move on to one of our final steps, which is the polishing. And now for this practice, there's a lot of things going on here. Is that we want to do multiple changes. We want to add like a price label and text underneath the labeling there of those pads. We want to add color variation to the trees. We want to scatter decorative elements like this around the world. And we want a golden tree also that gives us the triple the logs if it drops. You could have an AI execute against this. I don't think this necessarily needs a plan, but what I see here is that this is delegatable. We can give an AI a multitask for this. So I'm going to switch cursor to multitask mode, and I'm going to tell it execute against this. And what it's going to do now is it's going to look at this prompt, see that there's delegatable work, and it's going to spin up agents to execute against every single one. And why is this useful? Is that this actually does just save time. It's going to first figure out how does it actually break down, how does it actually delegate this, but and plan its approach. But once it delegates it, it's all going to execute as one, and you'll see a lot of pretty rapid changes happening, where like the price labels are going to appear, trees are going to change color, we're going to see decorations appear, and then a golden tree is going to be there. So yeah, this has been really good. By the way, I want to highlight a really good experience that I've found when using multitask, is that when you're bug fixing parts of your game, playtest your game, write down all the bugs that you find, and I mean all the bugs, and be descriptive on how you reproduced it or how you got to that point. and feed that to the AI as a delegated multitask list. And what you'll find is we'll go through and execute against it, and do it all pretty well. Okay, so it did. One of the agents did finish up, which is it did recolor the trees a different color. It is pretty green, but that's okay for this workshop. So you can see it has a little solid dot here, which means it finished. It is still scattering. It is still updating the price labels above the pads, which it did, and it now just finished the golden tree logic, and it is also scattering these pieces here across the world. So we'll see what it does. It hasn't quite finished up yet, but it's getting there. And then you can also see how it finished. So you can open up these individual agents and see what it did actually do to arrive here. But this looks great. We have a bunch of bright green trees. We have a bunch of plants around, got some mushrooms and ferns. And yeah, let's just go ahead and test this real quick. Okay. So I'm going to chop this one tree. You can see there's a gold tree in the back. Yep, that's there. That works. I sell off the logs, upgrade my click strength to 2, and that's it. Yeah, that looks great. We have basically a working game. Awesome. Okay, so what I want to do is I just want to recap real quick before we go to Q&A, is that really you should start with the architecture of your game, highlight essentially at a high level, like how your project's structured, what are the different, how do you make services like server scripts, how do you make client scripts, put the constraints in there, like don't use MCP for code, we're only using for data model. You also want to make sure you constrain and scope the changes. Data model hints are valuable, as you've seen, like being able to tell the AI where things are at already gives it enough context to, instead of just guessing and having to go explore that. You want to ground your prompts in architecture as well. So like telling it, hey, you need to go look at the architecture. Here are the starting values for various like variables or just like properties. And you also want to go ahead and do like asset referencing, prep the asset ahead of time as well. Like, hey, go use this asset if you're going to build this. Planning mode if you're gonna implement something very complex, and make sure you audit it and iterate on that plan if you feel it doesn't fit. I would never just accept the first plan blindly. It's just wasteful to build if you know it's not going to meet the requirements of what you want. Server authority is a must. You don't want to trust a client, obviously. So really name where the logic should live. Name the failure modes up front. Thoroughly describe the player feedback. Make sure you're building reusable pieces of code and emphasize that this is a reusable system. Describe the rules as well, and not just numbers. If you don't give it a fixed value or like the scaling, it will just make up everything. It will, and it's not. It can give you an undesirable result. Parallelize with subagents when you can, and additionally leave checkpoints. So if you see that there's a you've been coding for hours, it's been a long day, you want to end it there. You can tell the AI to summarize where it left off or what's unfinished as like an MD file. And then the next day you get on, you can go ahead and provide that, and then basically can leave off in a new context window. Yeah, and then ultimately, verify your work, plan it, iterate it, test it in a loop. Even a quick manual test, it counts. But yeah, that is essentially it. So I'm happy to break away to a Q&A.
Awesome job, Drake. Everyone, give a round of applause for Drake and leave your thoughts in the comments there. But wow, that was super informative. I love how, and I know you had mentioned like a lot of the prompts like were curated beforehand, but like thank you so much for showing us like what people can do for MCP and more so like what is possible out there too.
Yeah, of course.
But yes, everyone scan that QR code. We've also been having the link in the chat, so we do already have a couple of questions ready. So just jumping into the first one is, what IDE are you currently using?
So I'm using Cursor, and that's what I'm using. I'm using Cursor. It looks kind of different, but I am using a different theme. I like high contrast theme. It just reads better for my eyes. So yeah, using Cursor.
Gotcha.
You can use other cursors, by the way, too. There's so many other. There's other IDEs out there. So it's pick and choose which one works for you.
Do you have any that like you would personally recommend, or is like Cursor your go-to?
Cursor is like the top one right now in my mind. It's like everybody's been using VS Code if you're coding externally outside of Roblox. That's like the go-to IDE before we had Cursor. and like Cursor just has the agent harness for AI to be able to make changes within your code base, and as well as communicate with other software. So it captures everything, all my needs perfectly, and everything visually doesn't change. Like it's the same. I've been coding basically the same way I've been coding years ago, visually like this. So yeah.
Gotcha. And this question is from Cat212. Where has AI been genuinely reliable in studio versus where do you still write everything by hand or do things by hand?
Yeah, so AI is generally useful when you have like a system that you want to build and it is complex. So let's say you're working within a distributed system, and a good example of a distributed system is like a cross-server matchmaking system. Now, if you were to write that yourself, you can write it. Not saying nobody couldn't, but it takes time. There's a lot of edge cases. There's locking and whatnot. You have to communicate with multiple servers. AI is really good at making you sit in the position of thinking about how that system should be built, and it instead filling the gap of writing it for you. And for where it hasn't been like on the other side, on where it's not so useful right now for rapid testing or real time fast moving experiences, it tends to struggle in right now. Yeah, so those two are like that's essentially the part where AI begins to really struggle. It's just fast paced experiences because it has to really take time to think and reason about what it's going to do. So yeah, hope that answers your question.
Oh, yeah, for sure. And this is from Marcos Merlo 12. What are the best practices for managing context limits when feeding large Roblox code bases into an LLM?
Yeah, good. That's a very good question. So the way I look at it is that one, your architecture is imperative. You need to have a ground truth in how the AI should build within your code base. But when you do have like individual game systems, like let's say you have an inventory system or like a matchmaking service or something like that, the documentation should live inside the code. It should not live in another document. You also don't want the game system specifics to live in your architecture documentation. It doesn't make any sense. You're pulling in redundant information. So making sure you separate it out cleanly. And the thing is also is that with fitting all that information into a context window, these harnesses have built-in methods of compressing the context to make it more efficient. So you're not thinking too much about, oh, I need to make sure I write this properly in a way where it's like it needs a fit. You need to think about writing it in a way where it's specific enough and clear that it could land to where it needs to go. So you shouldn't have to really think about, oh, I need to make sure I don't go over 250K tokens or something like that. Or, the harness does a really good job managing that for you. But if you are building a new system, I want to highlight that you should start a new chat, feed in that high-level context architecture. This is what you're building. Here's the plan. Go execute against it. And that essentially what you're preventing there is a thing called context rot, where you have old context that is inside the window that is irrelevant. It's wasteful, and the AI that's obviously getting fed into its neural network, right? And it doesn't really need to have that. So a good example here could have been like starting a new chat during this exercise and then like building individual systems, but it would have to rediscover some parts. So but yeah, if you're building like a big system, it may be worth splitting it up into different chats. Don't worry too much about like keeping like everything within that context window. The harness should do a good job supporting it, and just be specific and clear ultimately.
Yeah, those are really good tips. And this one, I know you showed a lot about like what MCP like has done, like how great it could be as a tool, but what are some challenges when using LLMs and MCP within Roblox Studio?
Yeah, so just highlighted a few there, which was it does take time to test with the MCP. Like MCP, there's a playtesting agent that is underneath MCP right now in beta, and essentially you can kick off a play session, and then the AI can go in and figure out how to go and navigate and like do things for you, click things on screen, interact with the world. It is a little slow because it does have to deeply think. For us, it's natural. We just click, point, go do things, right? The AI is very methodical in its approach. So it can be a little slow if you're testing something that's like fast paced where it has to go across the world to go do something. Often it'll just teleport there, which is nice. But that it also doesn't effectively test the flows unless you're explicit about that, like you saw earlier, where it gave itself cache to then upgrade itself, which is not a player flow. So there's some challenges there. Another thing is that you have to really another challenge with MCP is you have to manage the constraint of when to use MCP and when not to use MCP. If you just not explicit at all, it will see, oh, I have MCP access, and you didn't say anything about it. It will just go and do whatever. It'll go off the rails and like make a change that wasn't intentional. So like a good example was, as I was iterating through these steps, I made a point where I wanted to polish the trees by making them different colors. That was one of the steps in the exercise. And I didn't explicitly state use MCP. And what it did is it went into the code and added it in the code instead, where they would switch colors anytime they spawn. But I was like, that wasn't my intention. I didn't want that. I want you to go ahead and use MCP to actually make the change in Studio, so it's visible to me. So it's important to be explicit. There's times where it won't use it, and there's times where it will use it. Just tell it how do you want to use it. Like use MCP here. That's all you need to say, really, and it'll figure out, okay, like how do I need to use that? So yeah.
Gotcha. And how should prompts differ from building, debugging, refactoring, and playtesting overall?
How should prompts differ from building, refactoring? So for building, the thing is, I don't really, I build with MCP, but it really is like setting up things and configuring objects. I don't really defer to it for art needs or like build this entire building. It will go into the toolbox, by the way. Like that's another cool thing, is it will go to the toolbox and find asset. When it comes to refactoring, AI is great for that, especially more intelligent models. If you're going to refactor like large chunks of your code base, really emphasizing what it should be targeting specifically, using a model like Opus, obviously like max reasoning if it's a very complex refactor. But yeah, if you have an intelligent model, you would want to ideally use if you have a really complex refactor, you want to use an intelligent model. And for testing, I mean, you've seen it. You could go ahead and have it take screenshots to verify that thing exists. It can mess up sometimes. It might assume something in the scene like is that fulfills that success criteria. So with that success criteria, it's important to just be explicit. Does the text labels appear above that thing? Does it zoom in on that? You want to just be clear. Don't just say, hey, does this exist? Because there's so many ways that's so like obscure. What does exist mean? It exists in the data model, exists visually, right? What if it existed in server storage? Technically, it still existed, So just be explicit. Yeah, I hope I answered that question. Yeah.
Yeah, and due to time, this is our last question, is
Mhm.
what command tips can I use to help the AI create more interesting and large games?
Yes, interesting large games. So okay, so the way I look at it is you when you're creating an interesting and a large game, right? Like interesting is subjective to you, but I imagine when you're saying an interesting large game, it's large in scope. So what you would want to do is you want to go ahead and have a GDD. Of course, you still want to take that approach of like understanding what game are you building actually. And when you do have that GDD envisioned, break apart every system into its own system plan on how it should be built, right? You can have these plans actually live in your code base in some way, like essentially where I have the prompts folder out here on the left side of the screen. You can have like the execution plans built out, and then you can have like an AI go through each one and make sure it all ties together to form a cohesive system, and then you can have the AI build against that. That's one tip. Just creating a GDD, be specific about what you want, how the system should be built, and just use planning mode and have it build that plan, and then look at the plan, audit it, iterate with it, have it execute. And when it comes to art assets, by the way, because that's also a complex space for game development. Asset referencing. If you have some already existing assets, tell it to use these assets. Yeah.
Yeah. Well, thank you so much for answering all the questions, and thank you so much for such an amazing workshop. So everyone, one last time, give a round of applause for Drake. And if you guys have missed out on any of the live challenges, don't worry, we have a lot more workshops coming up. At 2 p.m. PST, we have from player to leading a small creative team on Roblox workshops. So be on the lookout for that. But until then, I will catch you guys later. Thank you.
Thanks, everybody. Bye-bye.